Let's get started. The Pythagorean theorem is a theorem that involves only a right triangle. So it has to be a right triangle. If you recall, right triangles have to have at least one angle in the triangle that is 90 degrees. So just write that down in case you forgot that. And what the Pythagorean says is that the square length of the hypotenuse is equal to the sum of the squares of the lengths of the legs of the triangle. Okay, so this is the formula: a squared plus b squared equals c squared. Okay, now if you're wondering what is the hypotenuse, what are the legs, you can draw a picture of a right triangle, and the hypotenuse is always going to be the slanted leg, and it's always across the 90 degrees. So this is the hypotenuse right here. I'm going to abbreviate. It's always across the 90 degrees in the right triangle. And the legs are just the other two sides. The other two. We just use the word legs a lot when we're talking about right triangles. Okay. Now, what is the converse of the Pythagorean theorem? So the Pythagorean theorem says that the two legs squared is equal to the hypotenuse squared. So here on this triangle, I can label this as A, B, and then C. Okay, so the converse of that is that the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides. Then it is a right triangle. Okay. So basically, these two theorems go vice versa. So if you have a right triangle, then you have the Pythagorean theorem. And if you have the Pythagorean theorem, that means you're working with a right triangle. So it's just a back and forth thing, mainly. And it's good to know this because we're going to be classifying triangles. So let's get started with that. And here's our first example. It says, is this a right triangle? Is this triangle a right triangle? How would we know that? Well, if it's a right triangle, that means that the Pythagorean theorem should work. So who is my legs and who is my hypotenuse? These are the legs, and this is the hypotenuse. And if we write our equation, that means that a squared plus b squared should equal c squared. Okay, and now we just plug in values. So it's back to algebra. I'm going to use parentheses so we can see every input. 18 squared plus 80 squared equals 82 squared. And I'm getting those numbers from my image here, A, B, and C. And then we just actually do the math. So 18 squared, if you get a calculator, that's 18 times 18, which is 324. Plus 80 squared is 6,400. And then 82 squared is 6,724. Now, if this is a right triangle, then that means that when you add the two legs squared, they should equal up to the hypotenuse squared. So let's see if that works. I'm going to use my calculator. Where's my calculator here? Let me just split the screen. Okay, so this should be true. 324 plus 6,400. Does that equal 6,724? And the answer is yes. It is equal, which means that Yes, this is a right triangle. Okay. All right. Now, there's going to be a lot of scenarios where you will be asked to verify if it's a right triangle or not. So you would just do the same thing. But let's move on to our next vocabulary word, which is a Pythagorean triple. These are specific sets of positive integers. And that's another word for whole numbers. So if you want to put in parentheses, whole numbers. These are whole numbers that satisfy the Pythagorean theorem. So what does that mean? That means that if you have a set of three numbers, because a triangle has three sides, and they should satisfy the Pythagorean theorem just like it did up here when it satisfied here and it created a right triangle. So the question is, do the side lengths form a Pythagorean triple? So all it's saying is it going to satisfy the Pythagorean theorem? Because if it does, then these are a Pythagorean triple set of numbers. So let's try it. Now, question here. How do you know which one is A, B, and C when they're listed 4, 5, and 6? A good thing to remember is that the largest number is always C. So 6 is C. And then the A and B shouldn't really matter between these two, but we'll just go in order. Okay, so always remember that the hypotenuse is always the longest side. So let's plug it into our Pythagorean theorem and see if it's a Pythagorean triple. So 4 squared plus 5 squared, is it equal to 6 squared? 4 squared is 16, 5 squared is 25, 6 squared is 36. 16 plus 25 is 41. So that does not equal 36. So no, these three numbers are not a Pythagorean triple. Okay. I'll just give you a list of some common Pythagorean triples that are very well known. 3, 4, 5. That is a very common Pythagorean triple, which means that these three numbers, when you apply the Pythagorean theorem, they will work. They will form a right triangle. 5, 12, and 13 is another Pythagorean triple that's very common. And the third one is 7, 24, and 25. Okay, you don't have to memorize this. It's just a good to know for the Pythagorean theorem. Okay, I want to go over to the side where we actually do the Pythagorean theorem. So let's go over here and let's do this first problem. It's going to be on the inside of your notes. Just open up your notes and let's solve for the missing side link. So the Pythagorean theorem, again, a squared plus b squared equals c squared. Okay, and I'm going to label my side. So this is my hypotenuse. These are the legs. And this is another leg. So this is C and A and B. Okay, so let's just plug it in. 10 squared plus 10 squared equals, I don't know my hypotenuse, so that's just x and then squared. Okay, 10 squared is 100. So I have two hundreds here. Equals x squared. 100 plus 100. 200. Now, what do I do now? I got to solve for x. I have to find the missing side length. So this is where when we recall, how do you undo a squared? Because that is a squared right here. What is the opposite of squaring? The opposite of squaring is square rooting. Both sides. What you do to one side, you do to the other. And that operation will automatically cancel the squared. That is with the x. So I'm left with the square root of 200 is equal to x. Now, if you stop here, This is not a simplified radical, and when you take your test, your answer will not look like that. You will have to simplify the radical, which is the lesson we did before this. So let's simplify this radical. So if you have a list of your perfect squares, which perfect square will divide into 200? If you need me to write the list, it's 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144, I believe, is as far as we went. So, out of all of these perfect squares, who will divide, and who is the largest number that will divide into 200? Because 4 divides into 200, but that's not the largest. We got to keep going. And if you wanted to do trial and error, you would bring up your calculator and just start dividing. 200. So 200 divided by, I'm going to start with 144. Nope. 121. Notice I always start with the largest because I might as well start with the largest because I have to find the largest. 100. Yes, 100. 100 times 2. So I can rewrite this. Rewrite this. 100 times 2, right? And we want to simplify that perfect square, so let's separate it. What is the square root of 100? 10. And that is our final answer. We have to make sure we simplify the radical. There I go again. I wonder when I will make it right the first time. Nope. Let's just highlight it. I don't have time. Okay. That is our answer. 10 times the square root of 2 is equal to x. And it doesn't look pretty, but that's it. Okay. Good. Let's keep going with our notes on this side. This part right here, the triangle inequality theorem, we've done this already before. We did it last semester, so let's just review it. This is just to verify whether you have a triangle or not. Can the 3 lengths form a triangle? And what the theorem says that the sum of the 2 shortest sides should be larger than, greater than the third side. So what does that mean? It means that in this triangle, A plus B should be greater than C. Okay? And then you get some numbers and you test it out. So it's just addition. So here, this is A, B, C. So is 4 plus 5 greater than 6? 9 is greater than 6. So yes, these 3 numbers can form a triangle. So this is not the Pythagorean theorem. This is just to verify if these numbers can make a triangle. 3, 9, and 5. Who is the largest number here? 9. So 9 is C, and 3 and 5 are A and B. So 3 plus 5 should be greater than 9. 8 is not greater than 9. So these 3 numbers don't form a triangle. The next one, the largest number here is 19. Okay, so 8 plus 10 should be greater than 19. And that doesn't work either, so no. All right. Now, the next one, this is a very, very important theorem. It is the Pythagorean inequality theorem. And this is a way to classify the triangles, whether they're acute, obtuse, or a right triangle. So we already know that if it's a right triangle, then it should be a squared plus b squared equals c squared. That's the Pythagorean theorem right there. But for the other two, if it's an acute triangle, your a squared plus b squared, so your 2 shorter legs are going to be greater than the hypotenuse. And for an obtuse triangle, your 2 shorter legs are going to be less than c squared, less than your hypotenuse, okay? So let's give it a go with these. It says, given the 3 sides of a triangle, classify whether it's acute, right, or obtuse. Okay, so I have 4, 7, and 9. Who is the largest 1 here. 9. So that is C. The other two can be A and B. Okay. So let's just do the math. 4 squared plus 7 squared. Is it going to be greater than, less than, or equal to C squared? We don't know yet. So we're just going to leave a space. And then we're going to do 9 squared. Okay. 4 squared is 16. 7 squared is 49. 9 squared is 81. 16 plus 49 is 65. So is 65 greater than, less than, or equal to 81? That is very much less than. So what kind of triangle is this? It is an obtuse triangle. Okay. Next one, 10, 13, and 16. 16 is the largest, so that is C. And A and B can be the other two legs. So let's test it out. 10 squared plus 13 squared is blank 16 squared. Which one will it be? 10 squared is 100. 13 squared is 169. 16 squared is, I don't know, actually. 16 squared, that is one I don't have memorized. 256. Oh, okay, I should have that memorized, but I don't. 256. All right, what is 100 plus 169? 269. Is 269 greater than, less than, or equal to 256? 269 is greater than 256, so it is an acute triangle. This one is acute. Okay. And then the last one here, sorry, it's way here at the bottom. 56, 65, and 33. So these are big numbers. But if you want to pause the video and see if you can do it on your own, this would be a great chance to pause the video. So I'll let you do that. Pause the video. Try it on your own. Okay, if you're back from trying this on your own, or if you just waited until I started back up, it's fine. Let's do this one. The largest number is 65. So this is our C, A, and B. I'm going to do the work off here to the side. So 56 squared plus 33 squared. And then I'm going to square the C, which is going to be 65 squared. Okay. Those are big numbers, so let's just use our calculator for that. 56 squared. 56 squared. 3136. Okay. About 33 squared. Oops. 1089. Okay. And then 65 squared. 4225. All right, and then we add the numbers on the left. So 31, 36 plus 1089. 4225. So that is equal to 4225. So that means we have ourselves here a right triangle. Right here, since it's equal. Okay, so this is a right triangle. All right, so those are your three possible classifications of triangles. Now I'm going to let you attempt the last three Pythagorean theorem problems. So 1, 2, and 3. Please make sure that you're able to do all three of these problems, because then we'll start the regular practice. And then after that, we're going to move on to our next topic, which will be special right triangles. If you want to check your work for these three problems, please watch the other video explaining those three problems. And I hope you have a great day. Bye.